So far, the majority of the systems of equations that we've been solving have been linear systems, meaning you have two equations that are lines. Now I want to talk about solving nonlinear systems of equations. The important thing to remember for these type is that you will often have more than one answer, so definitely be careful about these. And for these problems, even if you are asked to solve it by hand, I still recommend that you draw a graph at some point just to take a look at it to make sure you're not missing a solution. Because you can look at graphs and think about how many intersection points they can have. If you don't have access to a graphing utility, like if you're taking a test like the AP exam for calculus, for example, or a college exam, I still recommend that you maybe draw a sketch and try to think about what the graph is going to look like and how many intersection points you possibly can have. So let's go ahead and do some examples. So my first example, I have the top equation is a line and the bottom equation is a parabola. I think it's really important that you know what they look like because that will tell you how many solutions you can have. So let's think about what this would look like. So if you had a line and a parabola, you have a few options. You can have something like this, where you have two intersection points. You can have something like this. In that case, you would have no solution. There would be, so I'm going to say no solution. This one has one solution. And the other option is, this one is a little bit more rare, where you only touch it at one point. And I just realized I wrote 1 up there. So you can have either 0, 1, or 2 solutions. Just kind of think about what it's going to look like. So we'll solve this one by hand. I do recommend that you also check this on your calculator to make sure that you are okay with graphing this on a calculator, but let's do this by hand first. So I'm going to start by using the substitution method. You can choose either of these equations and solve for either variable. And you can also, this one actually would work really well for elimination. If you were to multiply one of the two equations by -1, you actually would find something that you can eliminate and then you would have only one variable. Either way works for me. I don't mind which one you use. I'm going to do it by substitution. If you'd like to try the elimination method on your own, please do so. So this bottom equation, I can solve it for y. I can get y equals 2x squared. Then I'm going to substitute that into the other equation, which gives me 3x minus 2x squared is equal to -2. I'm going to move everything over to the right-hand side of that equation. When I do that, I get 2x squared minus 3x minus 2. This one is factorable, which is nice. You can factor it by doing 2x plus 1 times x minus 2. And when you get that, you set each factor equal to 0. I end up getting x equals -1/2 and x equals 2. These are both solutions, so this is a case where I have two solutions like this first one. I have a line intersecting a parabola at 2 points. You still need to continue on. You're not done yet. Keep in mind that even though it's two solutions, each solution needs to include both an x and a y value. So I'm going to substitute both of these things back into the original equation. So my first one, I had x is equal to -1/2. When I substitute that into my equation, y equals 2x squared, I end up getting y equals 1/2. When I substitute my other one back into that same equation, I end up getting y equals 8. So I'm going to make sure to write both answers out. I'll write them as ordered pairs. I get one at -1/2, 1/2. That's my first one. My second one is 2, 8. So those are my answers. Now, I do recommend that you try to solve all of these by graphing, at the very least, just to check your answer. I also would like you to be able to solve them by hand, but I think that being able to graph is also really important. When you do that, you will find, I'm not going to draw a perfect graph, but I'll give you a little sketch of it. You will find that your parabola is like this, and your equation or your line is like that, and you will have a point at 2, 8, and at negative 1/2, 1/2. So here's my second example. I want you to think about what are these two equations graphs of. For the top one, I'm hoping that you notice that this is a circle. For the bottom one, I'm hoping that you notice that this is a parabola. In the previous one, we could have 0, 1, or 2 solutions. In this one, there's a lot more options. So I can get something where I have a circle like this and a parabola like that. That one has no solution. I can get something where I have a circle and I have a parabola that touches it in one spot. That one has one solution. Other option is if I have a circle and I have a parabola that touches it in 2 spots. That's an example of a case where I have 2 solutions. The next one is super rare, but it doesn't mean it's not going to come up. Occasionally you'll have like the vertex on the parabola on the circle, and then you'll be touching it in 2 more spots. That's a 3 solution. And finally, you can actually have a case where you have a circle and you go through the circle twice with your parabola, and you could have 4 solutions. So just be aware that in this case, all of these are possible. And you might be able to imagine that the more solutions you have, the more work you're going to have to do, unfortunately. So there are a ton of ways to solve this type of problem. I'm going to show you one method that I really like and think is helpful. So you might be saying like, okay, I see that bottom equation. I can solve that for y. I can get y equals x squared minus 7. You can do that. However, an even easier way to do that would be to solve the bottom equation for x squared. I get x squared equals y plus 7. What I can do then is I can substitute in y plus 7 for the x squared in the other equation. I think this way is a lot faster than the previous way that I mentioned. So I recommend that you try that. You can try both if you want. Now I have something I don't need to do a lot of simplification of. If I had done it the previous way I mentioned using this, I would have had to do quite a bit of simplification. I would have gotten like an x to the 4th in there. It wouldn't have been really that pretty. It would have not been nice at all. So I'm going to tell you in another minute the other way you could have done this one that wasn't too bad. So now I'm going to just solve this out. I get y squared plus y minus 6 is equal to 0. This one, thankfully, is nicely factored. If I factor it, I can get y plus 3 and y minus 2 equals 0. So I end up getting a y value at y equals negative 3 and y equals positive 2. So before we figure out our x values, I do want to go back and tell you another way that you could have done this problem. You could also do this using the substitution method. If you had used the substitution method, my way of doing it would have been to recommend that you multiply the bottom equation by negative 1. And if you had done that, you would get you would get y squared plus y, these two would cancel out, these two would add together, is equal to 6. You'll notice that that's actually going to give you the same thing that we got over there. So either of those two methods would have been fine here. All right, so continuing on, we have y equals negative 3, y equals 2. We're doing pretty well. We have 2 y values. They are whole numbers, which is really nice. That doesn't always happen. If it's not going to happen, just use your calculator. I'll tell you in advance which ones you can use your calculator and which ones you can't. So I'm going to take now this bottom equation right here, solve that one for x. I get x squared is equal to negative 3 plus 7, which gives me x squared is equal to 4. Another thing that's really nice is 4 is a perfect square. I need to take the square root of both sides. Remember that when you take the square root of both sides, you're going to get a plus and minus. So I get a value at x equals positive and negative 2. This is for y equals negative 3. So right now I have two solutions actually. My first solution is negative 2, negative 3. My second solution is positive 2, negative 3. So keep in mind I do have two solutions there. Actually, if I substitute in y equals 2, I'm going to get 2 more. So I get x squared is equal to 2 plus 7, which is another perfect square, thankfully. I end up getting x equals plus or minus 3 when I take the square root of both sides. So that's going to give me a solution at 3, 2. And that gives me another solution at negative 3, 2. So this is actually one of those 4 solution problems. I would like to talk about how to solve this problem by graphing. I think that's a really important skill to have, being able to set it up so that you can graph it on your calculator. So the bottom equation I am going to solve by just solving for y. I'm going to graph by solving for y. I get y equals x squared minus 7. The top equation is a little bit more challenging. You'll find that if you solve for y, you end up getting y squared equals 13 minus x squared. I need to take the square root of both sides. However, what's going to happen when I do that is I get y equals plus or minus the square root of 13 minus x squared. So you might wonder, how do we deal with a plus or minus when we're putting it into our calculator? Actually, you're going to have to write it as two separate equations. You're going to have to write it as y equals positive 13 minus x squared, and you're going to have to write it as y equals negative square root of 13 minus x squared. So now you're going to put in 3 equations to your calculator. So go ahead, try to put these 3 in. I have y1 equals x squared minus 7. I'm going to put in y2 is equal to the square root of 13 minus x squared. And y3 is equal to negative square root of 13 minus x squared. I'm going to put all 3 of these in. Once you do that, you are going to be using the intersection feature. Make sure that you use the arrow keys on your, if you're doing this on your graphing calculator, use the arrow keys to go back and forth. The up and down arrow keys will move from one equation to another, so you can toggle between y2 and y3. And the left and right arrows will let you choose which intersection point you want to know the value of. So if you are trying this on your calculator and you're really struggling with it, let me know in class tomorrow. We'll do a little bit of practice then.